So at times, rather than having to calculate the probability of a specific value of x occurring, we'll need to calculate the probability that x be less than or equal to some value x. Yeah, and those are called cumulative probabilities. So for such probabilities, we'll need the cumulative distribution function, which is just a cumulative or summation of probabilities. So here's an example to help you gain a deep understanding on this. So a random variable representing a single dice roll has the following probability distribution. So we have 1 over 6 as the probability distribution. Now the cumulative distribution function will look like this. So we'll have 1 over 6, and then here less than or equal to 2 means you add the first two probabilities, so 2 over 6, and here you have 3 over 6, 4 over 6, 5 over 6, and 6 over 6, which is same as 1. Okay? Um, the median of a discrete random variable is the middle value. It is the value of x for which the probability is less than or equal to some value x. Yeah. So that cumulative probability is up to some value x. It should be greater than or equal to 0.5, and the probability that x is greater than or equal to that value of x should be greater than or equal to 0.5. This makes more sense in a problem. So the table below shows the probability distribution of a discrete random variable x. Find the median of the distribution. So basically, in this problem, we can see that the probability, and this is just by inspection, yeah, x is less than or equal to 6 will be equal to um, 0.2 plus 0.4, which is 0.6, and we can see that probability that x is greater than or equal to 6 will be equal to 0.4 plus 0.3 plus 0.1, which is 0.8. And because this meets the condition of the definition of how to find the median of x, we can now say that the median is 6. So hence the median is 6. Because probability that x is less than or equal to 6 is 0.6, which is greater than 0.5, and the probability that x is greater than or equal to 6 is equal to 0.8, which is greater than 0.5. Okay, so sometimes you may have a problem like this. Um, we have a probability distribution of discrete random variable x, and we want to find the median. So in this case, you can notice that the probability that x is less than or equal to 1 is 0.2 plus 0.3, which is 0.5. Just 0.5 here. And then probability that x is greater than or equal to 2 is again 0.4 plus 0.1, which is 0.5. So here the median should be the middle of these guys here. So the median here will be the average of these guys here, which will be 1.5.